Hello, everyone. My name is Said Wisal, CEO and founder of Zadida. Welcome back to our general session here at Zadida Transform. This is our last session for today. I'm super excited to get started. It's been quite a day. It's also been amazing content, amazing presentations. It really flew by. But with that, we're going to start now our last session. And I would like to introduce to you Sanjay Upal, who is a Senior VP and GM of Service Provider Edge at VMware. And Sanjay, welcome, and we'd love for us to hear from you around VMware's views on edge computing.
Thank you. Thank you, Saeed. And firstly, it's been an honor to sponsor this event. I've heard that you folks have had a wonderful time today, and I'm so pleased to be able to, maybe lend a few words and round it off towards the end. So I want to say a few things first about what does the edge mean for VMware. And so Leah, you can go to the next slide. Really, when VMware started, it was about abstractions in the data center, which started off with servers. So server virtualization, as VMware is, of course, very well known for. I think the very simple idea there was to have a layer of abstraction that hid the underlying hardware for operating systems that ran on top. I'm saying simple now. The idea was simple, but of course, its execution was very innovative and complex. This technology that came out and revolutionized what we could do for servers inside the data center. And that led to the next phase, which was what we called SDDC, or software-defined data center, which combined networking, it combined storage, it combined compute all together so that you could virtualize your data center. Then, of course, there was the advent of all the public clouds. But VMware extended the abstraction across the public clouds as well. So what we've done is said that there's a layer of abstraction that you can put on each individual public cloud so that your workloads, which are there in the private cloud or software-defined data center, you can extend it out into the public cloud. So you don't have to do a big lift and shift and shut things down and port them over, right? The porting word is not, doesn't go very well for people who have lots of IT to do. So we have this entire area now with private and public. And now, of course, there is multi-cloud, which leads into our strategy for multi-cloud, which we call Cloud Smart, which is don't do this in terms of going after individual clouds, just get another layer of abstraction, which of course we would love to be VMware, so that you can run your workloads regardless of whether it's private or public. And also each individual application that are being striped across multiple clouds, or for things like disaster recovery or business continuity, you may want to be in several public clouds anyway. And so this layer of abstraction gives you the agility to run on all those clouds at the same time. But now we're into what I believe is the most exciting part, which is the reason why we've partnered together with Zadida, is what's happening at the edge. So our belief, which is bolstered by a lot of data out there, is that the place where workloads are growing the fastest is at the edge. Now, of course, the volume is smaller, so the growth is much larger. And this has been talked about for many years, but I really think that it is happening right now. And it's happening because it's not so much if we build it, they will come. There used to be that about 5 or 6 years ago, where infrastructure was set up in various places at the edge, usually a multi-tenanted infrastructure. And with the idea that if you set up this infrastructure, then people will come and get their applications to run or workloads to run at the edge. That actually didn't happen. But now I think it's a much more pragmatic approach, which is to look at what are the individual use cases that people have for running workloads at the edge, and then using a digital infrastructure or an abstraction, as we say in VMware, then you use that abstraction to run this infrastructure on top. And I think this is the most exciting part, because we can see real use cases that customers have, whether it's retail or manufacturing or hospitality, logistics, utilities. Across all these verticals, there are these use cases coming up. And in my mind, they really, they are classified in two categories. One is there's voluminous amounts of data which need to be aggregated, and you need that infrastructure at the edge. Otherwise, you'd just be sending too much data back into the data centers or the clouds. That's one reason. The other reason is that there's just a lot of multimedia information, computer vision being very common, and then you need to do inferencing at the edge. And once again, you need that intelligence to boil the data down. Both of these are helped by machine learning models, as you folks have probably heard of today. So this is the evolution that we see. We're very excited about being partnered with Zedata and other folks and going after this. We think that this journey is right at the beginning stages. The business unit that I run, which is about networking or telecom and the edge, is one of 4 business units at VMware. But this is a business unit that's at the cross section of chaos, innovation, and growth. Chaos, innovation, and growth, which is really the intersection that I like to be at. So next slide. I just want to say that when we look at these, there are 3 areas. I'm going to walk through all of this, but we look at this edge infrastructure in terms of 3 different layers. And so you see the telco cloud-enabled 5G services as one of those layers. You might ordinarily not think about this as the edge, but in fact, it is the edge, because what's happening is that the network itself, the 5G network, is getting modernized, and it's getting modernized by becoming disaggregated. And the disaggregation is driving the need for a virtualization layer. And so you may have heard of the term vRAN and ORAN and all these terms from the 5G perspective, but that's certainly very similar to what we're thinking, working together with many of you folks in terms of what we're doing for the compute platforms where the applications actually run. So this is one layer of what's happening. And then you need a layer where the networking and security go hand in hand, because as you push these workloads out to the edge, you need that network and security infrastructure, ZTNA, the network resiliency. You need the zero trust to be able to get this all done in a zero touch manner. So there's lots of zeros out there: zero trust, zero touch. And actually, I'm pushing a third one, which is 0 watt. You need to really reduce the power consumption. But all of this drives the need for this SASE or SD-WAN infrastructure. And we have about 600,000 of these edge devices. One of them looks like this, that have been deployed. This is an edge. This is one of the VMware SD-WAN edges out there. And then the layer on top, which is the one that all these use cases are coming up for aggregating as well as computer vision, is edge computing, needs real-time decision making and application intelligence. So we think that all of this is tied together, and they can be sold separately. Sometimes the buyers tend to be separate, but if you tie them together in an infrastructure that can support different type of workloads, running 5G as a workload, or SASE as a workload, or edge computing as a workload, you get this amazing benefit of agility, as well as really getting to that zero touch. So you don't have a lot of manual work being done, because you can imagine that if you have, let's say, 50,000 cell sites where you have digital infrastructure across all of these cell sites, you want to upgrade to the next version, or you want to add a new feature to your 5G phone, and it's provided to you by the network. If there's any manual work that needs to be done, it's just will drive the business model out of existence, because automation is needed, orchestration is needed, programmability is needed, which is why these things coming together is very important. All right, next slide, please. And then, I want to end this part of it, and then we'll have a discussion with Said and get his viewpoint as well. So when we look at this across the RAN, across what's happening in the SASE layer, across what's happening in the edge compute, it's really the next step of where software is coming into what used to be hardware, right? So when you look at the RAN, or the radio access network, a lot of the hardware and software used to be proprietary and locked together. But once it's getting disaggregated and you get this layer of abstraction supported by virtualization, then it frees up the software, frees up innovation. You can come in and you can put features on the fly. I mean, it used to be like 10, 15 years ago, you wanted a feature from the network. I mean, it would literally take 2 years before the feature was conceived and before it got on. That was considered fast. Well, that's not fast anymore, of course. You want to feature it with CI/CD, and you want a feature that's developed today to be available tomorrow, but it also needs the security and everything to go along with it. So as this disaggregation happens in the networking layers, in the compute, where the 5G also is, it also is happening now on the factory floor. It's happening in the retail store. It's happening in the hospital. It's happening in logistics. It's happening in substations. It's just amazing how much disaggregation there is. That brings about a huge challenge. Once you disaggregate, who's going to put this whole thing together? How is it going to run? So this is where the challenges come in, and Zedata and other folks have gone out and put a stake in the ground and said, yeah, we're going to partner with people and solve this problem, because the disaggregation is a huge benefit, but there's a problem, which is, you've got to make this thing run with automation. It's got to run smoothly, and it's got to run not just for the install and the config. It's got to run for the install, the config, the operations, and the maintenance. all of that stuff is extremely manual and time consuming if not done well with the right set of tools. So this is a fantastic code. In fact, I was there, in one of these factories last year in the fall and saw, this is actually the part of where what's known as a marriage happens, which is the chassis comes together with the body, and you actually hear this sound like a big ka-chink, and then this marriage happens of the two, and then it goes on into the rest of the assembly line. And the amount of infrastructure that needs to be put in place, the amount of screws that need to be tightened, and all of this stuff that needs to happen, the more and more automation there is, the more features that can be provided on that factory floor, the faster the cars obviously roll out and the more features that can be put in. So here's a quote from Gerd, who says that, previously we used to do things in hardware. Now we just want to buy a piece of software to get it done. In order for that to work, you need that digital abstraction layer. You need that virtualization, whether it's VM based or container based, you need that, which is what VMware is all about, which is what we're driving towards. My peers are driving towards that in the data center. I'm driving that towards the edge. And of course, both of those things need to work together. All right, I don't want to take all of the time, in this monologue, but I want to have it now, open for a back and forth with Said and myself. And so, Said, it would be great if you come back on, and I will have the privilege of asking you the first question. So
go ahead, Sanjay.
So it's very nice to see you again. And I'm sorry I couldn't join you for drinks last night, but as some of you know, we're under this weird and amazing storm here in the Bay Area, and power has been gone off for 48 hours. In fact, it just came back a couple of hours ago, which is also a different story about the edge. But anyhow,
that's one way of 0 watts, but not the one you meant, I think.
Yeah, not the 0 watt. I wish I was 0 watt, then I would be completely self-sufficient, but I'm not. But Said, so thank you very much for allowing us to sponsor this event of yours. But I wanted to ask you, like, how did you get into this whole thing of the edge? Where was that?
The light bulb went on. Yeah.
Light bulb. When did that light bulb go off for you?
Great question. Yeah, no, I mean, Sanjay, and I think I kind of come from the same origins of being networking folks, and I think for people that really understand edge computing, it helps if you have a networking background, I think. And we've been building out networks, and my career started in the early days of the internet when there were not many websites out there. But I grew building out the first internet backbones, then went to broadband and connecting homes to the internet. Then I worked for Ericsson, and we were doing all this 4G LTE cool stuff and connecting phones to the internet. And so then after that, actually in 2010, Ericsson was claiming there would be 50 billion connected devices by 2020. That was very clear to me that IoT was going to be the next wave. And so when that happened, and you start thinking about, okay, we're connecting all these devices, and that in itself is a huge challenge. How do we do that a cost-effective way? But also the traffic flow is going to shift. And if you remember in the networking days, in the old days, you had mainframes, and you had, people would be connecting to these mainframes, and then it switched around, and we started consuming data and downloading data rather than uploading. But with these devices, it flipped around. We started uploading again into the network. And that's when it was clear to me that the only way how we can actually process and analyze that data would be by figuring out how to enable edge computing. And so I think of it as actually sort of a hyperconvergence of two, layers or two parts of the infrastructure. Everybody talks about networking, storage, and compute as sort of the three big buckets of infrastructure. We've seen obviously hyperconvergence between networking and storage in the data center in the last few years, and VMware's done some great work there as well to offer that to customers. I think edge computing is a lot about convergence of compute and networking. And what I love about our partnership with you, Sanjay, is I think the VMware vision of taking service provider edge and networking and putting that together in a single organization under your leadership, realizing that there is a lot of synergies with what you call chaos, innovation, and growth is actually, I think, absolutely the right strategy. So we've been really excited to partner with you.
Yeah, no, that's great. And you're absolutely right that the network, especially when you talk about the edge, the network is always a part of the conversation. And one of the very cool use cases that we were showing was the one that we worked together with you folks on as well, which is we were in Barcelona for the Mobile World Congress. And for those of you who came by, we had a Tesla car in our booth. And that Tesla car actually had an edge compute stack that was running at the back. And maybe there was a slide on it.
Yeah, Leah, maybe you can put up that slide, because that's actually a really cool slide. And I think it really talks about what is coming now in edge computing. I think, we talk a lot about factories and, machines and substations, but I think the mobile edge is where really I think the opportunity will be.
Yeah, this mobile edge is very cool. So you have an application that is running in the car. In fact, several applications. One of them is this ANPR, which is an automatic number plate recognition application. And then you have other apps as well that you can put on, like a digital forensics app. And these cars are driving around. As they're driving around, they're actually, the camera, this is the computer vision example. The camera is actually reading these license plates that are going by and giving real-time feedback to the police officers that are sitting in the car on, what are they finding out? Is this a stolen car? Is it not? Is it okay? Is the license expired? And things of that sort. And I actually happened to be in one of these cars in a ride along in the UK, in London, just a few months ago. Let me tell you, it was like a completely gut-wrenching experience. I'm so glad I did not have breakfast that morning, otherwise I would have definitely thrown up. But those guys go for it. They're sitting in the front, and even a fraction of a second, if you can give them more information about the crime scene or who the person is or that car, it can even save lives. So we have this situation here where you need this real-time feed, you need this digital infrastructure, you need to be able to put this in tens of thousands, if not hundreds of thousands of cars. You needed to stream live video. You need to make inferencing of what is happening. And this is where all of this comes together. It cannot be done if all of the data was being streamed up to the cloud. By the time you did that and got some answer back, something bad could have already happened. So a fantastic example, and you see all the technical part, the edge compute stack, there's a virtual vSwitch. SD-WAN, of course, is needed to tie multiple of the mobile links together to get them out. And your stack being an integral part of this, I think was very cool. This is just one example, but I wanted to share it with you and share it with all you folks who are on the call. Of course, Saeed knows this extremely well. So I'll turn it back to you, Saeed. Maybe you might.
Yeah, no, Sanjay, I think this is interesting because I think there's two things to discuss. And Leah, thank you for sharing the slide. But if you kind of think about it, I think first of all, from what I understand, is there's also a lot of these are electric cars and Tesla. So coming back to 0 watt, you probably care a lot about the weight as well as the power consumption of all of this infrastructure. I mean, it obviously cannot, take too much away from the capabilities of the car. And the other thing I would imagine, and I'd love to get your thoughts as you talk about this, is the scale. This is not, just a couple of cars that we're talking about. And any thoughts there about what you call 0 watts and the other thing we call zero limits in Zadida, and how those, fit into this?
Yeah, I think the scale is very important. So when we say edge, actually, there's so many different types of edges: thin edge, thick edge, far edge, near edge, RAN edge, enterprise edge. But really what we say is that the number of locations is critical. So it is digital infrastructure across a number of locations close to where the endpoints are producing or consuming data. Very, very simple definition of the edge. And so the number of locations is very critical because we're not talking about data center order of magnitude number of locations. We're talking about order of magnitude of cell sites. We're talking about order of magnitude of the different assembly points on a factory floor. You're talking about branch offices. And then you go one step deeper, you're talking about the number of endpoints they could be, number of people, number of things. And then you're talking, of course, into the billions that you were mentioning. So whenever we talk of that, even if you're at the first point of aggregation, this scale cannot be achieved without automation. We cannot get even the install and the config done without automation. We found this out, of course, as we were rolling out, Dish Network site. We've been doing that for a few years now, in a year and a half or so. And, this stuff about automation, and that's just about getting to 25,000 sites, but when you get to millions of locations, it requires automation. And that automation is critical. One of the differences between what happens in the data center, what happens at the edge, the other difference, of course, is one of footprint. The reason I showed you this device, of course, is, and your software is quite capable of running on these, is the footprint needs to be shrunk. So as I've said jokingly before, I should be able to stand up and say, honey, I shrunk the stack. Because not being able to shrink the stack, there's no way you can take that data center stack, and run it on devices or put it at the back of that Tesla. Those cars used to be filled with infrastructure in the trunk. And as you were rightly saying, the weight is very important. You need to get to that lower power consumption.
Perfect. Great. And then, of course, the other thing which I think is important to maybe highlight is scale on networking. I mean, these cars are driving around. They are obviously communicating back to systems in the cloud or data center or combination thereof. You've been building an SD-WAN to hundred thousands of locations already, but this could now add another 0 or 2 to it. What are your thoughts around how that networking scale can be accomplished? And maybe you could talk a little bit about sort of what VMware has been doing in that space as well.
Yeah, so networking for the longest time has been the underlay has been separated from what's done on the overlay. So SD-WAN was the first time when the overlay actually knew what was happening in the underlay and could make intelligent decisions about what to use in the underlay. So it's a very simple example of this is, if you have a broadband network and you have a fiber, let's say an MPLS-based network, and you have a really important application and the MPLS network is glitching, you want to actually take the packet and replicate it on both based on business policy, cost, and everything. But the overlay decides that. You know the capability of the underlay through measurement, and then the overlay makes that decision. That networking is now getting extended, of course, into all of the different wireless forms of networking, everything from NB-IoT to the millimeter wave 5G and everything. But the important change that's happening is programmability. There are actually layers now being developed. In fact, we were showing one in Barcelona called the RAN Intelligent Controller, where the RAN, the radio access network, could be programmed from the overlay, could be programmed from the layers that you're building, the layers that we're building, so that in the context of an application declares its intent, the overlay layer programs the underlay, gets a response back, and all of this happens in real time, so that when that police officer is at the crime scene, then the prioritization is how do we get that live video to help that police officer know what is happening 30 seconds before they get there. That would be extremely valuable. Would the police officer be willing to pay 50 pounds for that? I bet you they would, right?
Yeah,
So,
you need it, you need it. Absolutely.
These are the kinds of things that I think are going to open up a whole variety of use cases, and networking is at the core, of getting this thing done. That car that you saw, it uses 4 network connections, and the SD-WAN layer ties them all together.
Excellent. And then the other thing I really always, as part of a partnership, really think it's very exciting is that obviously the networking is one piece, but if you think about VMware at a broader level, I think VMware now, is available in data centers, in clouds, with our partnership and some of the other work you've done also on the edge. Can you talk a little bit about broader orchestration, the end-to-end? Because as a customer, obviously, you have applications that parts of them may reside in all these different areas or different environments, and your thoughts there and what VMware's vision is on sort of that multi-cloud and multi-edge orchestration.
Yeah, so I think we're very pleased from one sense that workloads are moving to the edge, because what VMware brings to the table is the virtualization of compute. Whether that is done through virtual machines or containers, it's really abstracting out the compute layer. And most of the dollars, interestingly, are with the compute layer. Yeah, of course, we networking people say that, we produce infrastructure that, saves money. And so, let's say that we can get paid, the security folks can get paid, but the major dollars are what happens when the workload and the applications get virtualized. And so VMware, what our belief is that just like we went from servers to software-defined data centers, and that was private, to the public, that is getting extended to the edge. So this digital infrastructure extends out, and it covers everything from the data centers to the edge. So an application that is being built, you have, again, in Barcelona, the telcos were talking about GSMA-based APIs, and you could think of APIs being exposed at the networking layer so that when you're writing this application, that you have the entire infrastructure, whether it's data center or the edge, at your disposal as your developer developing these apps. That to me is going to give us compute on demand, networking on demand. Of course, the ZTNA security has to get tied along with it. But this on demand, the networking on demand, has been the nirvana of all us networking people. Oh yeah, networking on. I mean, we were far away from that for decades. I really believe we are at the crux of getting this thing solved through programming, through automation, and through orchestration. It's all happening at the edge.
Totally. I totally agree. And the other thing that I really enjoy hearing from you is that you keep emphasizing the needs for both virtualization and containerization. And I think, one thing to share here is when we started with Zedita and we started working with industrial companies, energy companies, I don't think we realize actually how much still they rely on virtualization in these environments, because a lot of the applications that they wrote took them many years or decades to write. They're still based on often more legacy stacks, Windows. And while everybody in the data center cloud is used now to think in Kubernetes and containers, I still think the OT world is in a shift to that. So the ability to offer both, I think, has been critical. I know that the other thing that, we have obviously been discussing is also real-time virtualization and how we can even run control application, not only data analytics applications. So to me, it feels, VMware obviously started with virtualization in the data center, offered us a software-defined data center, which ultimately brought us to the cloud. But it feels like we're coming full circle back and actually running that kind of ability to help customers in their transition in their application flow and development. I don't know if you have any thoughts, if you've seen the same from your engagements.
No, quite right. I think a couple of aspects there. One is, of course, VMware has a lot of strength in IT, but the growth that is happening at the edge is happening at OT. Even if you think of what's happening in the radio access network or the RAN, as I mentioned a couple of times, when you look at a telecom operator, there's the IT part of the telecom operator, but then the OT part of the telecom operator is the network.
Yeah,
that is where their business actually happens. Same thing on the factory floor. That's the OT part. Same thing in the hospital. Where all of the respirators and the systems are connected. That's the OT part. And so this need of the OT part to get virtualized and whether it's containerized or not. I think that the real-time aspect of this is absolutely critical, because a lot of these decisions need to be made much faster than can be made to accommodate the round trip time from the cloud and back. And yes, you're right. The whole thing is coming full circle. Previously, we used to be sitting on terminals, getting access to mainframes that are sitting God knows where. The pendulum moved, and now it's kind of moving back. And so we have this distribution that is happening, and it's literally happening before our eyes, and it's extremely cool to see.
Yeah, absolutely. I totally agree. Well, maybe as a last question, 5G is a big deal. Any thoughts you have on 5G edge? And then,
you know what? The press has already started talking about 6G, like 5G is already done and dusted. I'm like, wait a minute, we're just getting started, guys. So I think, 5G has gone through a lot of change. And we do remember the bonded 4G that people used to call, I won't name them, that used to call 5G. But then there's so many flavors of 5G, of course, the millimeter wave and there's mid-band and all of this. But I think it's not just about the speeds and feeds, as you know very well. It's really, for me, it's about the programmability. And that programmability, just ask around, which telcos have a tariff to give you a network slice? How much are they going to charge for it? For how long? What bandwidth? What latency? We're at the beginning stages of this. So once the business innovation catches up with the technology innovation, the programmability and the promise of 5G, I think, is going to explode in the types of use cases. And I didn't even mention metaverse once. So even before the metaverse, all of this stuff, I think, can actually take off. And I think it's going to make, your company, quite successful. And we'd be very happy to continue the partnership with you. We think VMware is onto a very good thing in terms of extending our position in the data center all the way onto the edge and beyond. And 5G is an integral part of getting this done because of the programmability.
Perfect. Well, I think our partnership is a match made in heaven. It's been really a pleasure to work with you and your team. We're looking forward to do great things with you. And I think with that, I'd like to ask Paul to come on and take us to the last few minutes of Zedida Transform. Thank you so much, Sanjay, for joining us.
You're most welcome. Thank you. Thank you, Saeed. And thank you to the entire Zedida team and my team who's been working together with you.
Thank you. Paul? I think you're mute. Paul, I think you're still on mute. Can you unmute? All righty.
Sorry about that. Thank you so much. I'm worried about the camera and not the mute.
No problem. Take it away.
Thank you so much. Thank you, Sanjay. Thank you, Saeed. Thank you so much, everyone, for joining. Thank you for that great last session. For all of those that weren't here at the beginning of the day, my name is Paul Campanello, and I'm the VP of Marketing at Zedida. I would like to thank you all for attending today's conference. I'd like to thank our sponsors, especially our gold and platinum sponsors like VMware and Emerson and Rockwell and SUSE. I'd also like to thank all of our speakers. We had speakers and panelists and analysts, but especially Dr. Satya and Kelsey Hightower, who were two of our keynotes. We really appreciate their time and effort. Hopefully, you all attendees found it valuable. You were able to perhaps learn a few new strategies to help optimize your edge initiatives. If we can be of further assistance, we'd be delighted to do so. Please simply visit Zedida.com to engage with us. Additionally, all of the content that you've seen over the last day will be available on the VFairs website for the next 30 days. And during that time, we'll also port it all over to our website. So over the course of the next couple of weeks, it will be available in both locations. I'd once again like to thank all of our speakers, sponsors, and attendees. For all of those interested in participating in the iPad raffle, if you return back inside the auditorium into the platform, the VFairs platform will hold the raffle there. Thank you all very much. We appreciate it.